Hey, I'm making a storage shed in my backyard, and I'm at the point where I'm putting the roof together and making these roof trusses here out of 2x4s and a piece of plywood. Before I started putting these together, I had to decide how steep I wanted my roof. In mathematics, we call how steep something is the slope. Roofers call that the pitch of a roof. They talk about the pitch of a roof, how steep it is. And they often refer to how they talk about the rise and the run, just like you do with slope. Slope is rise over run, but they usually refer to slopes as something in 12, 4 in 12, 5 in 12, 6 in 12. And let's go up here and have a look at this. So again, if that's the angle of that the roof is going to be, roofers talk about how far in 12. If you go 12 inches over, how much does it rise? So if you have if you have a pitch of 4 in 12, for every 12 over it goes 4 up. Now I wanted it pretty steep here just to make sure ice and snow and rain and all the stuff out of the trees slides off of there. Plus then I get a bunch more space up here. I actually wanted a roof pitch that's more like 8 in 12. Actually what I have here is I have 3.5 feet this way for 5 feet that way. The building is 10 feet across, so half of it is 5 feet. The rise is 3.5, run is 5. Now I want to know how that compares to standard roof pitches, so I'm going to convert it to something in 12. I'm going to do that right now on paper. Alright, so to figure out how our roof compares to standard roof pitches, we're going to use some similar triangles here. Our roof is 3.5 feet the rise, and the run is 5 feet. Now we want to know how would that compare if this was 12. So I'm going to imagine that it's 12 feet. We want to know how high up does that go. If this were a similar triangle, which means if that angle is the same, which it is because it would be the same angle of roof, and then when we measure it, that's a right angle, we measure the rise, we're measuring straight up. And then of course, if you have two angles the same, the third one has to be the same. Those two triangles are similar triangles because all the angles are the same. That's our unknown. We want to know how high up does that go for 12. We can write a proportion here because a property of similar triangles is that the sides are in proportion. So 3.5 divided by 5 has to be the same as x divided by 12. Now to figure that out, we can just figure out how many times more that is and then use that same factor to multiply there. So we'll get our calculator. So we want to know now what's 12 divided by 5. So we know this is times 2.4, and then we know we have to multiply this by 2.4. So if we go 3.5 times 2.4, we have 8.4. So that's what our rise would be if it were 12. So we got a slope of about, well, 8.4 in 12. That's our roof pitch. All right, so that's about what I wanted before. I said I wanted it about 8 in 12. It's pretty close, a little bit more. All right. That's using similar triangles to find that length of that unknown side there, which happens to be the rise of the roof pitch. Now, while we have this triangle here, this ratio we use, this divided by this, or this divided by this, if you're looking at that triangle from this angle down here, that's the opposite side, and this is what you call the adjacent side. It's right next to the angle. That's an important ratio when you're talking about triangles and starting to talk about trigonometry. The opposite divided by the adjacent is actually the tangent ratio. And what we've looked at here is the tangent of this triangle has to be the same as the tangent of this triangle because those angles are the same. That's why trigonometry works. If you know an angle, you know the ratio. So if we divided this ratio, that would be the tangent ratio for those two triangles. So that's a little bit of a lead into trigonometry too. And that's it.